Welcome to Subaru Ecu Flash Training Part 8. This video we're going to be taking a look at working with fuel injector data programming. Now our fuel injector data is going to be characterizing how the fuel injector sets that we have installed on our engine are going to work. So this is going to be things like our injector flow rate, our injector latency, and a short pulse width style compensation. There's going to be a lot of details that we're going to go over here. I'm going to break down what each individual injector characteristic programming is going to be within our Ecu Flash software so you understand what it represents, and then working with an actual injector data characterization information from Injector Dynamics, we're going to learn how to program that in our actual file. We're going to have a lot to cover. Let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look and working with programming our fuel injector data characterization information into our Subaru ECUs. Now, we have to understand the basics of what's going on with our injector data, why it's so important. We're going to talk about that here in the first portion of the video. Towards the end of the video, we're actually going to go into injector data sheets provided from injector manufacturers to take the data and learn how to go and properly input it into our files. There's going to be some things we have to integrate. I have an Excel spreadsheet here that we're going to be utilizing. It's going to be found in our course packet folder. Again, all this information, all the course packet itself can be downloaded right into our course library. It's going to be the first icon you can click on. It'll be a downloadable link. It'll download the file right to your laptop so you can open everything up and follow along with what we're showing in this training tutorial. Now, again, we're going to go over the basics of what's going on with our injector data. You want to make sure that you have your two files open here, the two different file types. Again, we can find the sample files right into our course folder. We have a 2003 WRX file, and we also have a Carberry ROM loaded. So these are two things I want to take a look at. Now the 2003 WRX file, that's a stock file that I read out of a bone stock vehicle. We'll find that all of the coding, the XML coding, the definitions as we find available here in our current ROM metadata, that is going to be not as much as the Carberry. The Carberry has a lot of enhanced ROM or code that's been added to it. We'll find as a result it has more favorable injector data programming. You'll end up wanting to tune your car anyway with the Carberry based ROM. So what we're going to find here, and we're going to focus more heavily on in this video, is the Carberry ROM, but we will take a look here between these two different ROM types. We want to just have them open for reference sake so we can start off here in the training tutorial. Now let's talk about what is going on here and in terms of our injector data, why it's so important, because if you don't have your injector data programmed right, you're going to be introducing a fueling error which will carry through from idle part throttle and wide open throttle, meaning we won't hit the target air fuel we're requesting, and the ECU might be trying to fight that and trying to bring the fuel back up in line to the target. We can get into some odd behavior and make the engine run very poorly. Injector data is going to have probably one of the largest effects on how the engine will run if we don't have the data set up and programmed properly. So let's kind of break this down. Let's talk about the fundamental equation that we have underlining everything within our Subaru ECU. That's going to be fuel mass is equal to air mass divided by target air fuel. We've talked about this in the very first video in this training course. I was discussing the fundamentals of how the ECU operates, and this equation still holds true. And we need to know what this is going to be and what these various tables are going to be within this basic equation, because the translation of the requested fuel mass needs to get turned into an injector pulse width. So what it calculates for the ideal amount of fuel being delivered in the engine, that has to be represented through the injector size and the injector set that we're dealing with to actually pulse the injector open and closed to deliver the proper fuel so that we hit the air fuel that we'd like to go after as we're operating our engine. It's very important. Now, if we don't have this right, we don't have our injector data right, we can't translate that fuel mass into the actual fuel delivery to the engine. So these tables that we're going to be discussing a little bit later in this training tutorial are the keys to translating fuel mass into an injector pulse width specific to the injector set we're dealing with. All right, so the equation that we have to understand here is fuel mass is equal to air mass divided by target air fuel. So the fuel mass is going to be what we calculate. But first we need to go in and measure or know what the air mass is going to be. And then we also need to specify what we want the engine to run for a target air fuel. So if we know the air mass, we divide it by the target air fuel, we can figure out what the fuel mass is going to be. So the fuel mass is something we'll talk about here in a second. But let's break this down a little bit further, talking about air mass. In a stock equivalent file here, we're going to be operating in a mass airflow operation mode. So we're going to be looking at the mass airflow sensor. That's going to be registering the volume flow of air entering the engine. It'll know what the air temp and the barrel pressure is going to be. It'll figure out what the density of the air is going to be. Volume times density is mass. Therefore, we know the air mass. The tables that we need to go and take a look at here that we would need to pay attention to would be here if we jump down to the current ROM metadata. Looking down here into our information, we're going to find mass airflow engine load, MAF scaling. This is going to be taking a look at the voltage coming from our MAF sensor, looking at what...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.